Hello and welcome to Pre-Hospital Hub. Today we're going to explore P waves, including the different types of P wave morphologies that you may see on an ECG. So what are P waves? P waves are the first visible deflection on the ECG. It represents a depolarisation of the atria, or contractions of the atria, which initiates the cardiac cycle. The electrical impulse that causes the atria to contract originates in the SA node, or the sinoatrial node, which is often referred to as the natural pacemaker of the heart. So, as mentioned, P waves represent atrial depolarisation. So in normal circumstances, the right atrium contracts just before the left atrium, as the SA node is positioned closer to the right atrium. The combination of right and left atrium contraction forms the P wave. So the first third of the P wave indicates right atrium contraction. As we've mentioned, the SA node is located in the right atrium, so hence when we start having the electrical impulse, the right atrium is going to contract first. The middle third in the P wave is a combination of both atriums contracting, and the last third in the P wave indicates left atrial contraction, which makes sense again because this is the furthest point away from the SA node, so it takes longer for the electrical impulse to travel, hence the last third of the P wave is left atrium contraction. So what should a normal P wave look like? So a normal P wave axis is between 0 and 75 degrees. Depending upon which lead is viewed, and a P wave should be upright. So in leads 1 and 2, when the action potential originates from the SA node. Duration of P waves should be less than 120 milliseconds or 3 small squares. And the amplitude varies, so in limb leads it should be less than 2.5 millimeters or 2.5 small squares, and in precordial leads or chest leads this should be less than 1.5 millimeters or again 1.5 small squares. So the easiest way to view atrial abnormalities is looking at inferior leads, so leads 2, leads 3 and AVF. And V1, as P waves are the most prominent in V1 from the precordial leads. Limb leads are useful in identifying atrial abnormalities, whereas V1 is useful in identifying which atrium exhibits these abnormalities. So, normal P wave morphology. So when we're looking at lead 2, the right atrium is depolarized, followed by the left atrium, as we already know. The combined duration is less than 120 milliseconds, and the amplitude should be less than 2.5 millimeters in height. The morphology is described as monophasic, which means it has a single phase, so it's either positive or negative deflection, but not both. And it should have a smooth contour. When looking at a normal P wave morphology in lead V1, this is being described as biphasic, and this means it has both a positive and negative deflection phase. The view from V1 shows the right and left atrial deflections, but in opposite directions, so this produces a biphasic wave. So the positive deflection indicates right atrial depolarization, or right atrial contraction, and the negative shows the left atrium depolarizing or contracting. So if we move on to some morphologies, so for right atrial enlargement, so what would we see in lead 2 for P wave morphology? So if right atrial enlargement is present, the depolarization of the right atrium lasts longer than normal, as the right atrial is larger. The amplitude for right atrial depolarization, however, remains the same. However, due to the increased duration, it now continues to depolarize as the left atrial depolarizes. So now we've got a right atrial and left atrial depolarizing at the same time for a longer time, so hence the amplitude of the P wave is going to get larger. So as mentioned, the larger amplitude, as now the two waveforms are combined, so the amplitude is going to be greater than 2.5 millimeters, and the duration remains unchanged, less than 120 milliseconds. So when looking at V1 for right atrial enlargement, the P wave would have an increased height in the positive deflection, as this represents right atrial depolarisation. And remember, P waves in V1 are biphasic, so again, the negative deflection would remain unchanged, as this only represents left atrial and the positive represents right atrial. So in summary, for right atrial enlargements, P waves in V1, you would see an increase in amplitude in the positive deflection. So when looking at left atrial enlargement, so if we're looking at lead 2, this would cause the depolarization of the left atrium to last longer. So this would increase the duration of P waves greater than 120 milliseconds. A notch may also be seen, described as P mitral, which we will discuss later on in this video. When looking at left atrial enlargement for leads V1, we would have an increased widening greater than 40 milliseconds, and again the depth in the negative deflection would be greater, as left atrial enlargement represents a negative deflection, and if we've got enlargement, we're going to have a bigger area, hence why the increased depth or amplitude in the negative deflection. So we can also have biatrial enlargement, is when both left and right atrial enlargement features are present on the ECG. So if we look, so we've got our normal lead 2 and lead V1, and that's how our P wave should look in both of them leads. So when we're looking at right atrial enlargement, we would have increased height. When we're looking at left atrial enlargement, we would have increased duration, and that would show a P mitral pattern as well. So in biatrial enlargement for lead 2, we would see an increased amplitude, but also an increased duration. In leads V1, we would have an increased positive deflection for right atrial enlargement, a increased amplitude in the negative deflection for left atrial enlargement, along with an increased duration. So in biatrial enlargement for V1, we would have increased amplitudes and increased duration of the P wave. So looking at the different types of P wave morphologies now. So we have P pulmonal, which may be present in right atrial enlargement. So P pulmonal is identified by tall, peaked P waves, and this can be most commonly caused by pulmonary hypertension as well as right atrial enlargement. Another P wave morphology that may be present on ECGs is P mitral, which, as mentioned, can be seen in left atrial enlargement. P mitral is identified by the broad notched P waves and is mainly due to mitral stenosis, which causes left atrial enlargement. Another P wave morphology may be inverted P waves. So looking at inferior leads with inverted P waves can indicate a non-sinus origin of the P wave. Another video that covers PR intervals is on our YouTube channel, but if the PR interval is greater than 120 milliseconds, then the origin is within the atria. If PR interval is less than 120 milliseconds, the origin is from the junction. So looking at an ECG example now. So this is a 12 lead from a 29-year-old male athlete, and upon looking we can see some P wave morphologies. So if we look at the limb leads first, so leads 2 and leads 3 and AVF, so you can see we've got some P mitral in these leads, which could indicate left atrial enlargement. And then if we look at V1, we have a YP wave with a small negative deflection, which could again indicate left atrial enlargement. No right atrial enlargement features can be seen here, such as P-pulmonal in the limb leads, and no increased height of the positive deflections in V1, which again may suggest right atrial enlargement. So this ECG would probably show that this athlete had left atrial enlargement rather than right or biatrial enlargement. So I hope you found this video useful on P waves. If you would like any further information on P waves or any other ECG topics, you can visit our website at prehospitalhub.co.uk. You can also test your knowledge on ECGs using our quiz, and we also have a Q&A forum if you have any questions around ECGs or any other pre-hospital topics that you would like answering.